400 feet of steel now stands on the Texas coast. You can see it from miles away. It rises over sand and water like nothing else there. The building is called Giga Bay. It sits at Starbase near Boca Chica. Workers started stacking it in 2024. By late 2025, most of the frame was up. Each wall section weighs more than a loaded jet. Cranes taller than office towers set each piece. Every lift had inches of room. One bad move could bend months of work. This single building adds over 700,000 square feet of covered space. That is about 12 football fields under one roof, and it is only one part. Around it sits StarFactory and the mega bays. Together, they push Starbase past 2 million square feet. That scale changes everything. Because of that scale, the way rockets get built has shifted. Starbase used to feel like a test site. It now feels like a shipyard. StarFactory alone covers about 1 million square feet. That is bigger than many car plants. Inside, long steel rings roll down lines. Each ring weighs tons. Each ring becomes part of a starship. Machines cut, shape, and weld them. Robots move parts across the floor. Workers guide the steps. The goal is simple to say: build one starship every day. That is about 365 ships a year. No rocket site has ever tried that pace. Let that sink in. Starbase was never planned like this at first. Early on, ships were built outdoors. Wind blew across weld seams. Rain slowed work. Heat warped parts. In 2020, one tank burst on a test stand. It ripped steel like paper. That blast showed a limit. You cannot build a mass system in a tent yard. Rockets need the same repeat steps. They need the same checks each time. So SpaceX changed direction. They started enclosing everything. They poured thick slabs. They built Mega Bay 1, then Mega Bay 2. Each one rose over 250 feet. Each one allowed full stacks inside. That solved wind and rain, but it did not solve speed. Speed was the real wall. One ship every few weeks was not enough. The Mars plan needs hundreds. Launch plans need dozens a year. That meant the whole flow had to change. Parts could not wait on forklifts. Weld teams could not move ship to ship. The factory had to bring parts to people. That idea drove StarFactory. Instead of one giant hall, it uses long lines. Steel goes in one end. Sections roll forward. Rings become barrels. Barrels become tanks. Tanks get domes. Domes get engine plates. Each step has a fixed spot. Each spot has set tools. Each worker repeats one job. That is how car plants work. Nobody had built rockets like cars before. Think about that for a second. A starship stands over 160 feet tall. It weighs over 100 tons empty. It carries engines that cost millions each. Before, each one was treated like a custom job. Now they are treated like units. The reason is not pride. It is math. Every rocket used to fly once, then it fell into the ocean. That meant every launch burned a full build. That is slow. That is costly. SpaceX wants ships to land. They want boosters to come back. They want to reuse them like planes. But reuse only works if you can build many. You need spares. You need upgrades. You need to retire bad units fast. That only happens with volume. And this is where Giga Bay enters. The mega bays can hold full stacks, but they cannot hold many. Giga Bay is built to hold over 20 work spots at once. Each spot can hold a booster or a ship. Workers can stack, wire, and fit engines inside. Weather no longer matters. Cranes inside can move parts any hour. The roof is over 380 feet high. That clears a full starship stack with room left. That means a ship can be lifted, turned, and lowered inside. That cuts risk. It cuts delays. It cuts time. Which explains why this building matters more than it sounds. Tests grab headlines. Launches get clips. But factories decide winners. The Saturn V flew 13 times. Each one took years. The space shuttle flew many times. But each one took months of work. Starship is meant to fly often, maybe weekly, maybe daily one day. That only happens if production stays ahead of flights. A grounded ship should not stop the line. A lost booster should not stall the year. Gigabay makes room for that buffer. This push did not happen in a vacuum. It came from painful lessons. In April 2023, the first full Starship flight test lifted. It cleared the pad. It rolled in the sky. Then engines failed. The booster lost control. The ship was destroyed. The pad itself took damage. Concrete flew hundreds of feet. That stopped flights for months. The team rebuilt the mount. They added a steel plate. They added a water system. That system dumps huge water under the engines. It tames heat. It cuts shock. It protects the pad. That rebuild took months. During that time, ships piled up. They had nowhere to finish them. Outdoor work slowed. That gap pushed the factory push harder. 3 months later, Megabay work sped up. Walls went up faster. Cranes ran longer. StarFactory lines extended. Workers from Hawthorne moved to Texas. Equipment arrived daily. New machines showed up weekly. Each solved one block. One machine rolls steel. Another cuts it. Another welds it smooth. Each cut minutes. Minutes turn into hours. Hours turn into days. And days turn into weeks across a year. Here is a number that tells the story. In 2021, it took months to build one ship. By late 2024, they built several a month. By mid-2025, internal targets aimed for one every few days. The jump did not come from one trick. It came from hundreds. Better weld tools, faster ring rolling, pre-built wire kits, engine-installed jigs, lift points built into tanks. Each saved time. Each cut rework. Each raised output. Nobody talks about this part. Every time they speed up, something breaks. A weld cracks, a line jams, a tank fails a pressure test. One ship in 2022 burst at over 7 bar. That is about 7 times normal air pressure. It split the steel. Instead of slowing, they changed the steel mix. They changed weld passes. They changed how they checked seams. The next tanks passed. That cycle repeated. Build, test, break, fix, scale. And this is where the factory becomes the system. Starbase is not just one haul. It is a chain. Raw steel arrives by truck. Coils weigh tens of tons. They get unrolled into long sheets. Those sheets feed ring machines. Each ring is about 6 feet tall. 20 rings make a ship barrel. Rings go to weld stations. Robots tack them. Workers finish them. Finished barrels roll to stack spots. Cranes lift them. They get stacked into tanks. Tanks go to fit areas. Pipes and wires go in. Then engines. Each Raptor engine weighs about 3,600 pounds. It makes over 500,000 pounds of push. That is more than 2 fully loaded 747 jets. A super heavy booster uses 33 of them. Installing them used to take weeks. Now it takes days. Quick connect lines snap in. Lift tables raise engines from below. Crews bolt them in teams. One engineer said one booster went from empty to full in under 72 hours. That used to be unthinkable. Because of this, Starbase changed from a test camp to a build hub. That shift shows in numbers. By late 2024, over 10 ships sat on site. Some were for tests, some were flight units, some were pathfinders. Pathfinders are used to try new fits. They let teams test changes without risking a launch unit. That stock only exists if you can build ahead. And you only build ahead if you have space, which leads back to Gigabay. Megabay 1 can hold a few stacks. Megabay 2 added more, but they filled fast. When one booster sits for weeks, it blocks a spot. When one ship needs wiring, it blocks another. Gigabay spreads that out. Over 20 spots means one slow unit does not stall the rest. It also allows parallel work. That means different teams can do different steps at once. That is how output jumps. Stay with me here. This also changes testing. Before, a ship rolled from yard to pad. That trip took hours. It needed road clears. It needed escorts. Each move risked damage. With enclosed bays near pads, more can be done inside. Heat tiles can be added under cover. Tiles are fragile. They crack in hail. They chip in wind. Indoors, they last. Wiring checks can run longer. Pressure tests can start inside. That reduces rework. Now look at the layout. StarFactory sits behind the bays. It feeds them. The mega bays and giga bay sit closer to the water. They sit near the launch pads. That shortens moves. A finished stack can roll a few hundred yards instead of miles. That cuts time. It cuts crew hours. It cuts risk. Every saved move is a saved day. This is where pattern recognition kicks in. SpaceX did this before. In Hawthorne, they started Falcon 9 in a small shop. Parts moved by hand. Output was slow. After crashes, they rebuilt the line. They added flow. They added in-house tanks. They added engine lines. Output rose. In McGregor, they built engine test stands. They added more. They cut test wait times. In Florida, they built hangars near pads. They cut transport. Each time building space led output. Starbase follows that same pattern. Here is another number. StarFactory plus megabays covered about 1.5 million square feet by 2024. Gigabay adds up to 815,000 more. That pushes the complex near 2.5 million. That is about 45 football fields. Each field under roof means work can run in storms. It means night shifts can mirror day shifts. It means summer heat does not stop welding. That alone can double useful hours across a year. The near-miss moments made this urgent. In one 2023 test, a ship lost tiles on re-entry. Plasma burned through. The vehicle broke apart. That pointed to build flaws, tile gaps, glue limits, edge seals. Fixing that needs controlled rooms. Dust ruins glue. Moisture traps, air. Indoors solves that. Another flight lost control after stage split. That pointed to wiring and fuel slosh. Fixing that needs long test runs. Indoors gives stable power and shade. Each failure fed a building choice. Building these halls took local crews. Hundreds worked on frames, hundreds more on floors. Each beam arrived by truck. Each beam was bolted high in wind. One crew worked nights to beat heat. Another worked days. In August 2024, one storm pushed cranes. Work paused for hours. After that, management approved extra crane anchors. They poured thicker pads. They did not want lifts delayed. Those small choices stack. Nobody expected Gigabay to rise so fast. Early plans showed a smaller hall. Then the design changed. The height grew, the footprint grew, the work spots grew. Each change meant new permits, new steel orders, new crane rentals. Those take time. They pushed anyway because they had seen the block coming. Ships were stacking up. Without space, progress would choke. And here is the thing, Starbase is not the only Texas site. In Bastrop, east of Austin, SpaceX built a factory for Starlink parts. It already covers about 700,000 square feet. Plans call for another million over 3 years. That site builds circuit boards. It builds power units. It builds user gear. Why mention it? Because it shows a mindset. Bring work inside. Control steps, cut shipping, speed feedback. Starbase is that mindset for rockets, which explains why Texas now hosts such a huge footprint. Between Starbase, Bastrop, and McGregor test fields, SpaceX has millions of square feet in state. Each site handles a layer. McGregor tests engines, Bastrop builds electronics, Starbase builds ships. That vertical chain cuts delays. An engine problem can be found in McGregor and fixed before the next batch. A board issue can be fixed in Bastrop before install. That loop tightens when production grows. This matters more than it sounds for competition. Other launch companies build fewer rockets. They rely on outside suppliers. Tanks come from one shop, engines from another, wiring from another. Each adds lead time. Each adds cost. When one slips, the whole stack waits. Starbase pulls most of that inside. That is technical system mastery. It is not flashy, but it wins races. Here is a simple scoreboard. In 2023, SpaceX launched over 90 times across all rockets. No other company crossed 30. In 2024, they passed 100. Starship flights were fewer, but each taught more. Each flight needed new ships. The faster they build, the faster they test. The faster they test, the faster they fix. That loop is the engine. Buildings fuel it. NASA still plays a role here. Starship is tied to the Moon program. NASA plans to use a version to land crews. That brings money, it brings checks, it brings requirements. NASA reviews add steps. Steps add time. But NASA funds also push build standards. That forced SpaceX to improve wiring tracking. It forced better pressure records. Those systems had to be built into the factory. Megabays and Gigabay now include those stations. This is one place where NASA's needs shape the floor plan, and there is a contrast. NASA's big rocket, SLS, is built in older halls. Parts move between states. Core stages come from New Orleans. Engines come from California. Boosters come from Utah. Final stack happens in Florida. Each move takes months. Each change needs meetings. That structure limits pace. At Starbase, most steps sit within walking distance. That is a different game. Boeing also sits in this picture. Boeing works on SLS and crew craft. Their programs use traditional supply chains. Those chains value stability. They move slow. They avoid risk. That approach builds fine hardware. It does not build fast. Starbase is built for speed. Gigabay is not about one perfect ship. It is about many good ones. That is the shift. Because of this, production targets now look different. Internal goals talk about dozens of ships a year. They talk about boosters cycling. They talk about engines being swapped in days. None of that is possible without covered space. Weather would kill it. Moves would kill it. Storage would kill it. Gigabay solves storage. Megabays solve stacking. StarFactory solves flow. Let that sink in. A rocket site now looks more like a truck plant. Parts enter one side. Finished units leave the other. That was once called impossible for rockets. They were too custom, too delicate, too few. But those reasons fade when reuse enters. Reuse means wear. Wear means replacement. Replacement means volume. Volume means factories. Here is a reveal that surprised many. The floor loads inside Gigabay are extreme. Each spot can hold a full booster. A Super Heavy can weigh over 200 tons without fuel. The slab under each spot is thicker than highway bridges. Crews poured sections in layers. Each layer cured weeks. Only then did frames rise. That work started long before steel showed. People driving by saw nothing. Under their feet, the base was forming. Another reveal followed. Gigabay cranes are custom. Off-the-shelf cranes could not reach the height and still move heavy loads with precision. These cranes ride rails near the roof. They can lift full ship sections. They can slide them across spots. That allows one crew to move a stack without blocking others. That layout came from shipyards. It is rare in rocket halls. Here's a near miss that shaped that choice. In early 2022, a ship section swung in wind. It hit a stand. The dent forced scrap. That cost weeks. After that, indoor lifts became a priority. That incident sits behind the walls now. Another reveal sits in the doors. Gigabay doors are huge. Each leaf is taller than a 20-story building. They open to roll out full stacks. They seal tight to keep dust out. They include tracks to guide dollies. Those doors took months to design. Wind load alone could twist them. Engineers ran models. They added braces. They tested small versions. Only then did they order full builds. Now it gets good. Gigabay also changes testing order. Before, many checks waited until pad time. Now more can happen inside. Leak checks, power checks, software runs. That means a ship reaches the pad closer to flight ready. Pad time is expensive. Pads are shared. Reducing pad days frees launches. That raises flight count without building new pads. And because of this, Starbase planning now ties buildings to launch cadence. Each launch pad can support a certain number of flights. Each flight needs a ship and booster. Each ship needs build time. Each build step needs space. By adding space, they raise the top limit. That is strategic future positioning. They are not building for this year. They are building for the rate they want. Another reveal is how quickly designs change. Raptor engines moved from version 1 to 3 in a few years. Each change altered mounts. It altered pipes. It altered wiring. In a small yard, that causes chaos. In a line, you swap a station. You change a jig. That keeps output steady. Gigabay includes modular stations. Walls can move, power drops can move, airlines can move. That lets them retool without rebuilding. This matters because Starship is not done. Flap shapes changed, tile layouts changed, tank lengths changed, nose cones changed. Each change means new fits. New fits need room to test. Without room, change slows. With room, change speeds. Here is a concrete example. In 2024, teams tested a new heat tile mount. It used studs instead of glue in some areas. That needed drilling rigs. It needed torque checks. It needed pull tests. They set a temporary line in StarFactory. When it worked, they made it permanent. That took weeks. In a packed hall, that might take months. Another reveal sits in workforce numbers. Starbase now hosts thousands of workers. Some reports point to over 2,000 on site across shifts. Each needs space, lockers, tool rooms, safety paths, emergency routes. Gigabay includes those. It is not just a big empty box. It is a planned work city. That planning reduces lost time. Lost time kills scale. Think about the cost side. Building millions of square feet is not cheap. Steel, concrete, cranes, power, each adds up. But the return is pace. If a faster line cuts 1 month from each ship across 30 ships, that is 30 months saved. Time is money in rockets. It is also safety. More tests, sooner find flaws, sooner. That avoids late redesigns. When early Starship flights failed, critics said the program was stalled. They said explosions meant chaos. Instead of hiding, SpaceX built more. They expanded the site. They added halls. They poured more floor. That choice answered failure with capacity. Capacity answers risk with data. Data answers doubt with results, which brings us to where things stand now. By late 2025, Gigabay's shell is near done. Interior build-out continues. Mega Bay 1 and 2 run daily. StarFactory lines stretch long. Rings move almost non-stop. Trucks bring steel daily. Engines arrive from McGregor weekly. The yard is busy, but the work shifts inside more each month. You see where this is going. Once Gigabay fully opens, the next block will not be space. It will be testing pace. Can engines be built fast enough? Can pads turn fast enough? Those are good problems. They only show up when factories lead. Here is the last big reveal. Starbase is now large enough to support multiple full stacks at every stage. That means some ships can be dedicated to test, some to orbit, some to landing trials, some to cargo. They no longer all wait in one line. That unlocks specialization. Specialization unlocks mastery. Mastery unlocks speed. And speed unlocks the real goal. Regular flights, frequent landings, rapid reuse. Those change space access. They change satellite costs. They change moon plans. They change Mars timelines. None of that starts on a pad. It starts on a floor. Remember the early tents. Remember rings in the wind. Remember tanks bursting in open air. Compare that to today's enclosed city of steel. That is development in motion. Starbase is no longer just a place to test. It is a place to build at scale. Gigabay seals that shift. It turns open ground into controlled flow. It turns one-offs into units. It turns risk into routine. The progress is visible. The cranes are there. The halls are there. The lines are there. The ships are there. The next phase is output. When Gigabay fully turns on, the site will show what it was built for. More ships, shorter gaps, faster learning. That is the milestone. The factory came first, the flood of ships comes next.